Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. So as you can see, today we are here for a very important topic for class 9. Okay, this part 2 has many things for Pythagoras theorem. Before starting my video, huge thanks to all of you who have supported my channel so well till now. Keep supporting my channel if you found my videos and everything that I do in my videos informative and helpful. Leave a like, share and subscribe my channel. It motivates me to make better videos for you. So without wasting much more time, let's get into our important topic. So see, Pythagoras theorem in part 1 we already learnt about the theorem. This hypotenuse square equal to base square plus height square. Today actually we are going to learn about its conversions. Okay. So this is actually not straight cut type of sums. In each sum there will be some means different roots. You will see how we will do that, through which we have to get to our goal. So don't get panicked by seeing the sum. There are means very easy processes. You have to just follow them. Questions might be long, but it will be easier for you to understand the way I will do it for you. Just see, the question 1 is here now. See, question 1. First of all, I have a triangle. Somewhat like this, and then this gets, and here they have drawn a straight line with some names A, B, C, I think, yeah. And they also have some lengths here. Okay, so this is D. BD's length is A minus X. DC's length is X. AC's length is B. Wait, is it B or not? Yep. AC's length is B. AB's length is C. And AD's length is H. Okay. So here some conditions are there. So they are telling that AD perpendicular to BC. Fine. Prove that. Prove. What is the proving? C square equal to A square plus B square minus 2AX. Okay, that's no issue. So what we are going to do is, first see this, for this triangle ACD, it's a right angle triangle. Okay, so let's do that. What we have here for triangle ADC, I suppose, what is the hypotenuse B? AC or the hypotenuse B? B square equal to base square, DC is the base, which is X, base square plus height square, height is AD, which is H, so H square. Now what I am going to do, I will take H square in one side, then H square will be equal to what? B square minus X square. Okay, then keep it as 1. Done. Then for triangle ABD, that's also right angle triangle. Okay, here hypotenuse is AB, which is C. C square equal to base square. Base is A minus X or BD. Plus height square. Height is AD, which is H. Okay. Or C square equal to A square plus X square minus 2X plus H square. Again, then H square will be equal to what? What will be H square? C square minus A square minus X square plus 2X. Right? Just shift the values here to this side, then H square will remain. Suppose this is 2. Then we have in 1 H square equal to B square minus X square. And in 2 we have H square equal to this. That means both these values are equal. From 1 comma 2. This will be equal to this h square. Both values are for h square, right? b square minus x square plus c square minus x square, a square minus x square plus 2x. Now what happens here? See, minus x square on both sides gets cancelled out. What remains? Or b square equal to c square minus a square plus 2x. And then here what you can do is, keeping c square in this side, you can shift all the other things to the left hand side. Or c square will be equal to what? B square. This will become plus x square. This will become minus 2x. And that is actually the required proof, right? This is equal to I can write a square plus b square minus 2x. You understood that? That was very easy, right? For both the triangles, we got the Pythagoras theorem, and from the equations for h square, from 1 and 2, h square's values are these two. So this will be equal to this. Then we just simplified it, nothing else. X square got cancelled out, minus x square, and then just converted into this form by bringing all the terms to this side and keeping c square in one side. That's a very easy question. So that's what you have to do. You have to means from equations have to convert it into the required proof. Okay, it will be very easy. Don't worry, I'm telling you. See, this was a hard question seemingly. You can get confused by this type of proofs. But whenever you just keep proceeding using the Pythagoras theorem, no, you will go to the goal. Let's see the next question. Very well. Question 2 on your way. ABC is a triangle right angled at B. ABC is a triangle right angled at B. Okay. Aim is a point on BC, not midpoint. Prove. Well, this seems to be a good question, I think. Let's see. AM square plus BC square equal to AC square plus BM square. What? That's something new, right? You will see what is conversion. Hello. You have given a question, but you don't know what is the diagram. First of all, ABC is a triangle right angle at B. That means it's a right angle triangle. Right angle triangles are like this, and here. Well, it went good. It is right angle at B, so this is B. And then I can take this as AC. Then naturally M is a point on BC. Suppose this is a point M. Okay. This point, suppose. Now see, what if I join AM? Don't you get two right angle triangles? AMB and ABC, right? Yes. Let's do this, okay? Or from triangle ABC, hypotenuse square or AC square equal to base square or BC square plus height square or AB square. Okay. And then here I have from triangle ABM. This one. Okay, let me just see one thing. Yeah. hypotenuse square am square equal to base square bm square plus height square ab square. Now, for my convenience, you will see what is it. I will shift, it means ab square equal to what? Am square minus bm square. Okay. Suppose this is 1, this is 2. So you got that from the two right angle triangles, we got two equations. That's no harm. Now, what if I do AC square minus AB square? Then AC square minus AB square. That means this value and this value will get subtracted, equal to BC square plus AB square minus AM square, and here minus minus plus BM square. Okay, very well. Is there some mistake? Let me just check. Square minus BC square. Okay. Alright. So this becomes, what, did we have to add the equations or something? Yes, I think we have to add the equations, guys, here. Okay, so it is no need to do subtraction, just add up the equation. Okay, then that will be much more easier for you. Then this will be my plus am square minus bm square. That's okay. Then what happens here? See, ab square on both sides gets cancelled out, right? So this becomes, or AC square equal to BC square plus AM square minus BM square. Now see, then AC square, and if I shift minus BM square to this side plus BM square equal to AM square plus BC square. Square plus BM, yes, absolutely. That's it. That is the required proof, right? See, okay, I can just turn this LHS to RHS and RHS to LHS, or AM square plus BC square equal to AC square plus BM square. Hello, that's the answer. Absolutely, that is the proof required. So how we got it? From the two triangles, we got the respective Pythagoras equations. What I did here, for my convenience, I took AB square to one side and the other remaining people to the other side. Okay. And what we did, AC square plus AB square, that means these two also get added. And just like that, when we get added these two, this AB square on both sides gets cancelled out. And this part remains. Now what did I do? I shifted Mr. minus bm square to this side. It became plus bm square, and these two remained on that side. When I just turn this upside down, or left side to right side to left side, and that's the required proof. That is the answer. That's how you have to do. Frame the equations, either add the equations or subtract the equations, then you will obviously get the proof. It's not that hard. Okay, this is conversion for you. Let's see the next question. So far so good, actually. Very well. Let's see the next one. Again, it's a triangle. And I am writing triangle like this. Okay, triangle ABC. B equal to 90 degree. Angle B equal to 90 degree, comma D is the point, D is the midpoint of BC. Okay. Very well. Then they are telling prove what? What to prove? AC square equal to AD square plus 3CD square. Okay. This is what we have to prove. First, let's draw this triangle. So D is 90 degree. That means this is a right angle triangle. Okay. So let's do that. Let's draw Mr. Right angle triangle. Something like this. Yeah. And B is 90 degrees. So suppose this is the 90 degree angle. This is B. And suppose this is C and this is A. Okay. They are telling that D is a midpoint of BC. So suppose this is the midpoint D here. Okay. So what if I join AD? Okay. So then let us solve just like the previous one. Let's get the two equations for the right angle triangles for angle ABD. What is it we have here? So AD square equal to AB square plus BD square. Okay. And similarly for this triangle ABC, we have AC square equal to AB square plus BC square. Okay. All right. Now, what if we add these two equations? Let's see. AD square plus AC square equal to what? Okay. Is it good to add or will it be better to subtract it? Let us just see that. So, what if I do AC square minus AD square? Okay. What will it be then? Equal to AB square plus BC square minus AB square minus BD square. Purpose served, Mr. AB square. See you soon. You have been removed. Okay. Or AC square equal to AD square plus BC square minus BD square. Okay. That's fine. That is very well. Now see. Here, what do we have? Okay, BC. We just see one thing. So BD is equal to DC, right? Yes, BD is equal to CD. Okay. Yes, absolutely. This is very good. Let's see. Why? Why is that? Because see, D is the midpoint of BC. Then BD will be equal to CD. Okay. Then here BD, this BD will be equal to CD, okay, plus BC square minus CD square. Why I did it, you will understand. Let me write it here, okay, or AC square equal to AD square plus BC square minus CD square. You understood that? BC's midpoint is D, that means BD equal to CD. BD equal to CD. I just wrote it CD instead of BD for a purpose. Now, see another thing. Here, we just see BC. How can we do that? Okay. Yes, CD equal to what? 1 by 2 BC. That's also another thing. Why? See, CD, this CD. BC's half is either BD or CD. Then CD here will be equal to half of BC. Then, or I just substitute this, then this becomes 2CD equal to BC. Okay. What will be that then? See this, or AC square equal to AD square plus 2CD square. BC equal to 2CD plus 2CD whole square minus CD square, or AC square equal to AD square plus 4CD square minus CD square, or now the final line actually AC square equal to AD square plus 3CD square. I think that's the proof we have to find. Yes, very well. So what we did again, first of all, for the two triangles, right angle triangles ABD and ABC, get the respective Pythagoras equations. Okay, then I did AC square minus AD square equal to, this will become this minus this, and AD square got removed. Good luck, AB square. Then remained AD square plus BC square minus BD square. BD is equal to CD because D is the midpoint of BC. Okay, so I wrote CD here. Now, CD was equal to half of BC. It is quite relevant from this figure because D is the midpoint of BC. Okay, then 2CD equal to BC. So here instead of BC I substituted 2CD plus 2CD square minus CD square. This became AD square plus 4CD square minus CD square, and that is plus 3CD square. So AC square equal to AD square plus 3CD square. So you have to means observe. See, in the question they have given our means solution actually. D is the midpoint of BC. So from that only we can understand that BD equal to CD, and either BD or CD equal to half of BC. From that you can go to the end. So that is conversion. Okay, not that hard. To just observe properly. Let's see the next one. We are going so far so good. Question 4 now. In a quadrilateral, ABCD, angle B equal to 90 degree, comma angle D equal to 90 degree. Okay. Prove that 2AC square minus AB square equal to BC square plus CD square plus DA square. Okay. So let me tell you, it's a good question. Okay. Quadrilateral. Okay. What is this quadrilateral for you? Suppose like this four-sided figure. So here, suppose this is ABCD. And they are telling that this B is a 90-degree angle, D is a 90-degree angle. Now, what if I join AC by suppose a dotted line? Okay. Then if I do that, you get two right angle triangles, right? ADC and ABC. Okay. So let's do for them what we have to do, Pythagoras theorem. So here what do I do? Or here for ADC, for triangle ADC. Okay. So hypotenuse AC square will be equal to AD square plus BC square. Base square plus height square. We all know that. Okay, let's say CD. Okay. Yeah. That's fine. Now for triangle ABC, another right angle triangle is there. Everyone should be given equal importance. A triangle ABC. Now again hypotenuse square or AC square equal to AB square plus BC square. For my convenience, I will keep AB square in one side. So equal to AC square minus BC square. There you go. Suppose this is 1 and this is 2. Now for our Mr. Proving, let's go for LHS. LHS 2AC square minus AB square equal to, now see, here I have AB's value as this one, okay. So I will substitute it equal to 2AC square minus, okay, minus AC square minus BC square in brackets, okay. Oh, no, not that square, not that square, okay. That will be horrible. Okay, this is okay. Now let's open up the brackets. Equal to 2AC square minus AC square minus plus BC square equal to what? AC square plus BC square. Now, what we got for AC? We got for AC as AC square, AD square plus CD square. So let's substitute that value for AC now. Equal to AD square plus CD square plus BC square. Sorry. Now, isn't that the RHS? I think accidentally we got the RHS, or did we do the correct thing? Yes, this is the correct process. Okay, equal to RHS. Proving done. That's how easy it is. So in all the cases, what you have to do first, get two equations. Mostly from the Pythagoras theorem. Just like I've done here for the two right angle triangles. For my convenience, I took AD square in one side for triangle ABC. Okay. Then what I did for LHS, 2AC square minus AB square will be equal to 2AC square minus AB square's value is this. Okay. So I am writing from 2. Remember this you have to write from where you are getting. Similarly, from here, from AC square's value, I have substituted as AD square plus CD square from 1. That's how to do. So I substituted AB square's value here with AC square minus BC square. Open up the brackets, got 2AC square minus AC square as AC square plus BC square. AC square's value was this, I substituted it, and that's the required RHS, I think. Okay, AD equal to DA, that's no harm, and that is the required RHS. Finished. So easy. So never be confused. Frame two equations. Go for the left hand side. Then try to solve it using those two equations. You will succeed 200%. Okay. Let's the next question. Question 5, I think. Yes. Okay. Some figure, I think, is given to us. Okay. Guys, I'm telling you, this is the means big sum. Be aware. Don't get means tired of it. It's a very means good pattern. You will understand soon. First, let me add a question. Okay, this pen of mine is going to sleeping mode. I don't know why. Okay, let's use him. In the following figure, which figure? We will see soon. Okay, OP, OQ, comma OR are drawn perpendicular very good sum to sides. See my pen. Just adding up to this much is going to sleep. But why, man? Yes, let's try to understand with this one here. In a bad condition, my pen. To sides BC, CA, AB respectively. AB respectively. Okay. Okay, that's what. This is nothing else than this. Now we have a proving. Proof. What? Okay. AR square plus BP square plus CQ square equal to AQ square plus CP square plus BR square. Okay. Challenge accepted. See, now I'm not drawn the figure till now. So from this so-called language of the question, it might be hard for you. But still, let us see what is the given figure. It can be easier for us to understand if you have the figure with us. First of all, a triangle, of course. Okay. Then I have, they are drawn three perpendiculars like this. Okay. It's like a Y type of a figure, perpendiculars. Three of them. And then some figures, names for them A, B, and C. And these perpendiculars, they are P, Q, no, RQP, RQP. RQP. And some right angles are there for your convenience. This is a right angle. This one is another one. Okay. There's another one as well. This one. Okay. Okay. So, okay, let me just draw it a little bit more correctly so that can be there's a purpose. Yeah, this is correct. And then this one and okay. This is not hard, okay, I'm telling you. It's interesting. So see, we can't means we don't have the game with us if we have this figure. We have to convert it into something. What I have to do is I have to join RC and QB. Okay. Okay, so this is O. This middle point. This is O. He is a means good customer. He is going to help us a lot. We'll soon find out. Okay. Now let's do it. This one is O. And then let's join these two. Like this. And then like this. Okay. Alright. Join. Now see. What do you have with what do you have here? Okay, we also have to join AP. Then you have 6 right angle triangles. You observe properly. ARO, OQ, then ROB, BOP, POC, and OCQ. So these are the 6 right angle triangles. For each of them, we have to do the Pythagoras theorem equations. How? For these values, we have to means this equal to what? This BP equal to what? For each triangle, we have to calculate. Okay. You will understand what I am trying to say. So using the Pythagoras theorem, let's get going. It's going to be easy. For triangle ARO, your hypotenuse is AR square equal to RO square plus OA square. Oh, not RO, I think OR I should read. Yes, OR square plus OA square. Okay, that is fine. AR square equal to AO square plus RO square. But is that correct? Let me just see. This triangle is means confusing. AR square. Is this the hypotenuse? Yes, like this. Okay. Yes, this is okay. So AR square equal to OR square plus OA square. Okay. So that's for triangle ARO. Then for triangle AOQ, AQ square, okay, equal to AO square plus OQ square. That's all right. Then for triangle BOR, or BOR. So which will be the hypotenuse? This one I think. Yeah. This is the hypotenuse. OB square will be equal to BR square plus OR square. OB is the hypotenuse. Then this is the height, it's the base. Plus OR square. My pen again going into death mode. I don't know always. Okay. Now what we have to do here? Remember that what I told you. For we have to means for BR we have to get the values. Okay. Only then you will be able to do the proving very easily. Or BR square. This will be equal to OB square minus OR square. Okay. This is alright. Then for triangle, BOR is done BOP. So many triangles. For triangle BOP, this is quite easy. Okay. So for triangle BOP, OB square equal to BP square plus PO square, right? What happened to that pen now? The pens are not working. That means my problem. Okay, let me use blue. If the blue can help us. Triangle BOP, OB square equal to BP square plus OP square. Yes, BP square plus OP square. Okay. Then this becomes, for BP I have to calculate a BP square to be equal to OB square minus OP square. How many triangles are done? 1, 2, 3, 4. 2 remaining. Okay. Then BOP done. Now triangle POC is there. And the COP. Triangle COP. So for triangle COP, OC square will be equal to OP square plus PC square. That's fine. OC is the hypotenuse equal to OP square plus PC square. That's okay. Now for the PC CP. For CP I have to calculate. Or CP square will be equal to OC square minus OP square. Okay. Sorry. Then the last triangle. Okay. Who is it? Triangle COQ. COQ. For COQ, see here. So for COQ, CQ square will be equal to OC square plus OQ square. Alright, CQ the hypotenuse in this case. Then this becomes what? Then, so okay, no, wait a second. So OC is the hypotenuse, right? Yes, OC is the hypotenuse. If you rotate this triangle, this is a right angle, then OC is the hypotenuse. Alright. OC square equal to OQ square plus CQ square. Then for CQ square equal to OC square minus OQ square. Okay, so we have here 6 equations. AR, AQ, then BR, BP, CP and then CQ. So now what I'm going to do, here see, AR square plus BP square plus CQ square equal to what? AR square is OR square plus OS square. Then BP square is equal to OB square minus OP square. Plus CQ is CQ square OC square minus OQ square. And AQ square, then I will do AQ square plus CP square plus BR square equal to what? AQ square is equal to AO square plus OQ square. Okay, let's see one thing. AOQ. AO square plus OQ square. Okay. So here if the right angle was there, let's see. Like, this is a complex one. Okay. So we will have to just keep checking. When these two additions become same, no, that is the correct answer. Okay. Then CP square it is equal to OC square minus OP square. And then BR square is BR square. Where are you? Okay. OB square minus OR square plus OB square minus OR square. Okay. Then see here. OC equal to OC square, that's okay, minus OP square plus OP square plus OB square minus OR square plus OR square. So this something here is not right. You just see. For triangle ARQ, okay. So this is all right. These four will get cancelled out. So you just see guys one thing. Okay. So what is here? AQ square, this triangle AOQ. Just see AOQ for here. Suppose this is a triangle, okay. Like this it's given. The right angle being here. This AOQ. So if I just get the right angle to that side and change the triangle, it becomes AQO. So AO is the hypotenuse. Okay. So here we will have some correction. Yeah. AO square. AO square will be equal to AQ square plus OQ square. Okay. Then AQ square will be equal to, or AQ square equal to AO square minus OQ square. And similarly here, AQ square, AO square minus OQ square. Okay. And I think that's all right. Yep. Now see, OR square and OR square. Okay, okay. Another one is there. Another one is there. OR square and okay. So this triangle. AR square equal to OR square plus OA square. We see that as well. So something is not right, I think, here. So for triangle now see ARO. Triangle ARO. How is it given like this? This is the right angle here. So yes, here see AO square equal to AR square plus OR square, right? AO square equal to AO square equal to AR square plus OA square. Okay. Then for AR square plus OR square, sorry. AR square equal to AO square minus OR square. Then here AR square's value. Okay. AR square value it is OR square plus OA square. Okay. So it is OA square minus OR square. Alright. Now I hope that it will be okay. Yes. See. Now what you have here? OA square and OA square get cancelled out. Minus OR square minus OR square get cancelled out. Plus OB square plus OB square get cancelled out. Plus OC square plus OC square get cancelled out. Minus OP square minus OP square get cancelled out. And minus OQ square and minus OQ square also get cancelled out. Then you get AR square plus BP square plus CQ square, AQ square plus CP square plus BR square. And that is the required proof. So that's what you have to do for each of the 6 triangles. Get the Pythagoras equation. Carefully see the right angles how they are given. Okay. See for AOQ here, the right angle was given here. So if I just rotate it, this one becomes opposite. Then AO square equal to AQ square plus OQ square. So keep these little things in mind. And then you can frame the equation by adding the first 3 and then equal to the last 3 for this equation. Okay. That's the answer of this question. So I told you it's a big question. Don't get tensed. Sorry. You will come to the end. So that's the answer. Let's see the last one for today. All the conversions have to be done by Pythagoras theorem, okay? And most of them are like addition and subtraction of one or more equations to get the desired proof. Nothing else. Let's see the last question. Question 6. Okay, another triangle is given to us. Good question again. Conversion questions are fun to solve. So it is like A, B, C, D again. A, B, C, D. Where is the right angle? Yes, on AD the right angle is there. Okay, that's fine. And they have given some details to us. In this figure, AD perpendicular to BC, comma BD is to DC equal to 1 is to 3. Nice. Proof. Two AC square equal to AB square plus BC square. Alright, no issues. So see, BD equal to what then? Here the sum of ratio 1 plus 3 equal to 4. Then BD equal to what? 1 by 4 parts of BC. Isn't it? See, BD plus BC means gets 4 parts. BD is 1 by 4 parts. Okay. Of what? BC. And DC is what? Or CD rather. CD is what? 3 by 4 parts of BC. That's okay. Okay. Then now, for the two right angle triangles, we have to frame the equations. For triangle ABD, here, okay. Again, see, the right angle is on this side. So we have to means rotate it like this. So we come, you just rotate the right angle, become ADB, I think, yes. So here AB square equal to AD square plus BD square rather. Okay. And here another one is there for triangle ADC. AC square, the hypotenuse, equal to AD square plus BC square. CD square. Okay. Then now, what if I do AB square minus AC square? This will be equal to AD square plus BD square minus AD square minus CD square. Okay. Cancel out this AD square. It remains BD square minus CD square. Now, BD is 1 by 4 BC. Okay. Or AB square minus AC square equal to 1 by 4 BC square minus CD square, which is 3 by 4 BC square. Simple mathematics, or AB square minus AC square equal to 1 by 16 BC square minus 9 by 16 BC square. Equal to what? Or AB square minus AC square equal to 1 minus 9 by 16 BC square. 1 minus 9 is minus 8 by 16 minus 2 BC square. Okay, no. 1 minus 9 is 8. Minus 8 by 16 BC square means minus 1 by 2 BC square. Okay. Then this becomes, if I shift this 2 to that side, okay, I shift this 2 to this side, I just cross multiply, or 2AB square minus 2AC square equal to minus B square, or not B square, BC square. Okay. Now what we have to do? Some rearranging, okay, to get our desired result. So what we have to rearrange? Here what I have to do is, I have to shift 2ac square to one side and the other things to the one side. So 2ac square to this side means it will become plus 2ac square equal to, I shift minus bc square to this side, it becomes plus bc square. 2ab square plus bc square. Finished. So easy. What we did? BD is to BC equal to 1 is to 3. Then sum of the parts is 4. BC equal to 4 parts. Means BD is 1 by 4 of BC. CD is 3 by 4 of BC. Then frame the Pythagoras equations for both these triangles, okay. And then we subtracted the second one from the first one. And we got BD square minus CD square. BD's value is this square minus CD's value is this square. Then did some calculations, cross multiplication, rearranging to get our desired proof of this one. So this is what is called conversion, where you have to frame the Pythagoras equations. There can be 1, 2, 3, 4 or 5 to 6 maximum, and add or subtract one of those or few of those equations and you will get the desired proof. So that is the end for Pythagoras theorem for class 9. The chapter is completed. Congrats. We did the Pythagoras theorems basic sums in the part 1 and some conversion sums in this part 2. So then, if you found my video on Pythagoras theorem part 2 for class 9 informative and helpful, and all these conversion type of sums and all the sums from this chapter were solved and clear to you, leave a like and share and subscribe my channel. It motivates me to make better videos for you all. The next video, a new chapter for class 9 is coming up. We will see what is it. I will reveal in that video starting, not now. Till the next video, with a lot of love from my side to all my little brothers and sisters. Take care and goodbye. Thank you.